now let's move on to transfer function, system algebra, and block diagram. So we have here the input, system, and the output. So in time domain to frequency domain, which is the time domain, we use small letter x, small letter t, and small letter y. So in time domain, we use the operation convolution. Then in frequency domain, we use the operation multiplication. So in frequency domain, we use capital letter X, S, and Y. So we have also the transfer function, or h of z. It is the ratio of y of z over x of z. So in transfer function, from convolution, we convert it into multiplication, or from frequency domain, converted it into time domain. So for us to understand well this transfer function, we have some examples. Now let's have an example. So we have here a simple block diagram. Let's try to get the y of n. So we have the x of n to z raised to negative 1. It becomes z raised to negative 1 x of n, and the operator plus y of n. We have here the n domain and the z. So let's transform the z to n. The final answer will be x n minus 1 plus y of n. Let's have another example. But this time, we will use feed forward block diagram. Sorry. Okay, so this is an example of a feed forward. Let's try to get the y of n. Y of n is equals to x of n to z raised to negative 1 and another z raised to negative 1. So let's combine this 2z raised to negative 1. It will become z raised to negative 2 x of n plus this feed forward from x of n. So it will become x of n plus another feed forward from x of n to z raised to negative 1 to the operator. So z raised to negative 1 x of n. Now let's transform this z to n. The final answer will be x n minus 2 plus x of n plus x n minus 1. So that's the final answer. So let's have another example, the feedback example of a block diagram. Okay, so let's try to solve this one. First, the x of z to z raised to negative 1 and another z raised to negative 1 will have z raised to negative 2x of n plus the feedback from y of n to z. So z raised to negative 2 y of n. Let's now transform the z into n. So x n minus 2 plus y n minus 2. Okay, so we have here another example for transfer function. And we need to get the h of z. So y of z is equals to we have here three systems, z1, another z1, another z1. So we combine it. So it will be z raised to negative 3x of z plus plus the feed forward, which is c raised to negative 1 x of z plus the feedback from here to z raised to negative 1 and to this 3. So z raised to negative 4 y of z. Okay, so we transpose this y of z to this part. It will become y of z minus z raised to negative 4 y of z equals to z raised to negative 3 x of z plus z raised to negative 1 x of z. Okay, then simplify. Let's simplify this form. 1 minus z raised to negative 4 y of z equals to z raised to negative 3 plus z raised to negative 1 x of z. So we need to get h of z, which is the ratio of y of z and x of z. It is equals to z raised to negative 3 plus z raised to negative 1 all over 1 minus z raised to negative 4. So this is now the answer. Okay, so we have here an example of block diagram which is in parallel form. We have the x of s, frequency domain, x of t, or the time domain. So remember that when we solve a block diagram in x of t or in time domain, we will use the operation of convolution. While in frequency domain, the x of s or the y of s, we will use multiplication operation. So let's try to solve first the y of t. So y of t is equals to x of t. This is the x of t convolution h1 of t plus x of t convolution h2 of t plus x of t convolution h3 of t. Okay, so we try to simplify this by factoring out the h of 1, 2, and 3. It will become x of t convolution h1 of t plus h2 of t plus h3 of t. So we have 3h which is in parallel. Let's get the h of t. H of t is equals to h1 of t plus h2 of t plus h3 of t. Since we have this h of t, for this 3h, let's simplify our answer. It will become x of t convolution h of t instead of writing again this 3h. Okay, so now let's solve for the y of s. In y of s, we will use the multiplication and not the convolution. So same process as here, same procedure. We have x of s multiply h1 of s plus x of s multiply h2 of s plus x of s multiply h3 of s. Okay, simplify this. X of s multiplied by h1 of s plus h2 of s plus h3 of s. And we have h of s rather, which is equals to h1 of s plus h2 of s plus h3 of s. Okay, the final answer will be y of s equals to x of s multiplied by h of s, which is equals to h of s is equals to y of s over x of s. So in block diagram in series, we have x of s, h1 of s, h2 of s, and y of s. In time domain, it is x of t, h1 of t, h2 of t, and y of t. So let's solve for y of t. Y of t is equals to x of s, x of t rather, convolution h1 of t. So notice that these two, x of t and then x1 of t, from these two to h2 of t. Okay, so in that case, we will also convolute these two to h2 of t. Okay, so we have h of t is equals to h1 of t convolution h2 of t. So the final answer is h of t is equals to x of t convolution h of t. So that is the same as the y of s. just change the operation from convolution to multiplication.